Excellent. So hi, everyone. As mentioned, my name is Jessica David, and I'm here to talk about our lovely Python monorepo here at Elastic. It's about our philosophical debates, lessons that we learned, and where we are going from here. So first of all, who am I? I'm a security data engineer at Elastic. I'll explain a little bit more what that is, some future slides. I have worked on pretty much all things data for the past 5 years. I've worked on SQL data warehouses, Hadoop stuff, SysOpsy, DevOpsy things, worn almost every hat you can imagine. So I basically like to call myself a career data pusher. I'm also a devoted cat mom. Some of you who saw earlier, that's Xander. He's not going to make an appearance, I think, after this, but I do love my cat. So our agenda for today, we're going to talk about how my team moved our code into the monorepo, how we kind of decided the Python tooling that was going to support this, configuring all this Python tooling, and kind of what we liked, what we didn't like, and where we see ourselves going in the future. I will note there's about 5 other 30-minute talks in here, so I'm going to go into a lot of high-level information, and some things may get breezed over a little bit, so do feel free to throw some questions in the chat. The one thing I will kind of point out definition-wise, though, is what even is a monorepo? You may be sitting there going, I don't even understand what that means. So it's short for a monolithic repository. It essentially just refers to a repository, so either SVN, GitHub, CVS, whatever your choice of tooling, refers to a repo that contains multiple projects instead of being split into multiple repositories, which may be called something more like a polyrepo or multi-repo, depending on who you're asking. It's kind of sort of like a microservices-like architecture where you have like a little project for everything versus a large repo for all of your code. Google and Facebook and other organizations use this. It's slightly becoming more in vogue when you talk about like a monolith versus a monorepo and all that stuff. The Wikipedia article on this actually has some really great information in it, so I've linked it in there in the slides in case you want to do a little bit more in-depth reading. So let's get started. So how did we get to where we are in this giant repository? So I want to explain a little bit who we are at Elastic. First of all, for those who don't know, Elastic is the company that runs Elasticsearch. We are a search company that you would use to potentially run on your website. So if you use either Uber or Instacart, if you do a search in there, you're using Elasticsearch behind the scenes. We're also a lot more, though. We do have a lot of really awesome observability and security products. And with that security product, there's me. I'm on something called the protections team. We protect the world's data from attack. If you use the latest Elastic security software and you get a little thing that pops up and says that we blocked some malware or ransomware, that's code that my colleagues are working on. So the researchers and data scientists on my team create artifacts for the endpoint. Us as the SDE team, we will gather user telemetry and third-party data to help with supporting these artifacts. And we're creating data pipelines pretty much on a daily basis to enable our team to continuously improve. So we're checking hashes, we're gathering alerts that come in from security endpoints and analyzing them to make our protection software even better. So in the before times, the code was written in Go for the user telemetry. We have OCaml, which is a functional programming language. If you haven't used it, I can't think of a good parallel right now. Maybe like a Haskell-y kind of thing. But there's OCaml code in there for third-party and hash data, and just a little bit of Python, usually used by our data scientists. But they were spread across multiple GitHub repositories. And I work in a team that used to be part of a company called Endgame, and they were acquired by Elastic in late 2019. So in the move to Elastic, all these GitHub repositories were merged sort of into one for the protections team. And across these individual repositories, there were varying code standards, library versions, even Python versions. So it was kind of the Wild West in all these repositories. So this is where the monorepo steps in. And we wanted it to be basically a one-stop shop for maintaining and deploying our artifacts in all of our data pipelines. We wanted to make sure there was consistent testing across everything. We were integrating correctly into the environments as well as into people's like local development environments. And also just deploying everywhere in a consistent way, whether it's a pipeline going out or anything that the developers needed on their laptops. We also wanted to apply code standards and language versions across all projects because as you may or may not know, in January 2020, Python 2.7 was no longer officially supported. So we wanted to make sure everybody was at least on a Python 3 version and ideally the same Python 3 version. I'll talk a little bit more about that later. We also want a better sharing of libraries between projects. So for example, we do run our own Elasticsearch client in some of our code. And do we want 7.6 in one, 7.9 in another? Do we want to make sure everyone's always on latest? And we want to be able to put a standard across everything, as well as creating our own internal libraries to support. But why Python if we had so many other languages to choose from? We like it. We like it for a lot of reasons. There's a lot of really good uses for it, including data science, web apps, API development. It fits our team's MO very well. More widely known within our team as well. OCaml is sort of a very niche language. So as we start to grow as a team, we want to make sure we have a language that's accessible to all. We're really excited about the latest 3.x updates. We really can't wait for pattern matching to come through in 3.10. For the OCaml developer on our team, he's very excited because that's something OCaml actually does very well. And we just generally love Python. We're big Python fans. We want to support the community and see it grow. So now that we knew we were in a monorepo, how did we get to where we were in terms of our Python tools? So this is where the philosophical debate portion comes in. We had 3 big questions, lots of other smaller ones too, but for the purposes of the presentation, we kind of had 3 philosophies that we wanted to kind of think about, which were how we can ensure code can be formatted and executed in the same way across multiple developers and environments, adding some kind of type assurance. We'll talk a little bit more about that later. And what can make our developers the most productive while maintaining high coding standards? We didn't want any tooling to sort of stand in the way of developers getting things done. The benefit of something like a polyrepo is it doesn't matter if you're using n different kinds of libraries or don't flake one and do flake another. So we wanted to make sure everything was very consistent. So this kind of led us down this path. So I'm going to break this down to a few subsections. So one is linting and formatting. For those of you who may not be familiar with linting, we're basically looking for syntactic validation. Is it PEP 8 compliant? Is it nice Python-y code? For black, we want used for formatting. So that will format all of our code per specification. So for example, if you're running in Vim or VS Code, it will make sure your lines are the exact length that you've defined. So we're a weird team and set our line length to 120 because we like really wide lines of code. So it will tell you and throw errors when that's not there, as well as some white spacing issues. Excuse me. We're also using isort, which will ensure that our imports are always in the same order. I don't know if you've ever been on a team where multiple developers have multiple theories and ideas as to how they like to sort their imports, but I've seen some people who like to sort them from shortest to longest. I've seen some people sort them alphabetically. I've seen some people sort them in a million other ways, and isort just removes all of that pain for you. I linked a helpful overview in here if you're following around the side, along with the slides, sorry. It's VS Code specific, but it also gives a really nice introduction as to what Flake and Black do if you need some more introduction there. For static type checking, these subtitles here may indicate how this is a little strange potentially if you're used to writing Python with no types in it. Working with an OCaml programmer who's very type strict, we really wanted to make sure we got a little bit of typing into our Python. And while Python is dynamically typed, using these type checkers is actually really useful. Your code looks a little bit bulkier, but it runs so much more nicely, and you can find out when things are broken much sooner. So for our static type checker, we're using Pyrite. You may use something like MyPy in your code, and this is essentially the VS Code equivalent of that. It's developed by Microsoft. You can use it using an extension called PyLadies in VS Code, and it allows us to strictly type our Python, which is nice. We are still having ongoing debates, though, about what should and should not be typed. There's a lot of consternation about that, especially when you think about small experimental projects. Like, do you really want to go through all that effort when it's kind of just experimental code? So we're still thinking about it. There's still work to be done there. Quickly on building and packaging, we create our code into executables into something called a PEX, which is a Python executable. We're using Poetry to help manage how we package those PEX files as well as our dependencies. And finally, we're using make, which is a pretty common bash tool for writing the steps that will build our PEXs, get all the requirements from our Poetry configuration, and more. I could talk about this for about half an hour on its own. So there are some links in there if you're unfamiliar with PEX and Poetry, and would highly recommend looking into Make. Those of you on Unix-based machines are probably familiar, but if you're more of a Windows person, highly recommend checking it out. And some other supporting players. So another one we have is pre-commit, and this helps supply Black, Flake8, isort, and Pyrite rules before you commit. So in our GitHub repo that you have locally, if you run a git commit, it will check all your Python files before you push them up to make sure they're linted correctly and formatted correctly. And yeah, we use GitHub to store all of our code. We like to leverage some GitHub actions for some automated tasks on creating pull requests and things like that. And Jenkins is our continuous integration tool of choice. It will run some linting checks when PRs are created, as well as doing some builds for us. So Jenkins is our tool there that we love. But now, how do you configure all of this? This is a lot. And we're going to talk about some configuration madness. So in this slide here, this is a very simple layout as to what our repository looks like. I say very simple because the whole thing can't fit on a slide, so do bear with me. As you can see, everything in pink is a directory, the blue is files. So we have 3 top-level directories where we store some of our major projects, which are in libraries, tools, and services. Services usually involve something like an API. A library is usually shared code used among projects, and tools are things like things we need to run like on a once-in-a-while basis to help maintain our systems and pipelines. So in each directory for Python code, we have a makefile and a pyproject.toml file, as well as any optional tool configs. We have, as you can see over here, we have global Flake configuration. We have our pre-commit configuration. We do use PyEnv and are working on that integration to have consistent Python environments there, as well as a global makefile, another pyproject.toml file, and our Pyrite configuration. But you can override these 2 things in each project. We also have our general make files here, and you can override all of the make targets in your make files too, or add additional make targets. As I said, we're into configuration madness. So here be the dragons. So that's just how many configuration files do we need in our monorepo. As you saw, we have multiple pyproject.toml files, and this is the file that Poetry uses for finding all the dependencies. It's essentially used in replace of requirements.txt or requirements.in file. We need to have our Flake8 and Pyrite config files alongside the pyproject.toml file, so we can't have all of them in one, which is a little annoying. Our pre-commit configuration also as well sometimes doesn't inherit the properties from our other config files, and sometimes they don't work in the CIs the same way they do locally because the Docker container versions may or may not be slightly different, and oh my god, what is happening? So this is what we looked like for a very long time at the beginning of our Python monorepo adventures. So we're trying to figure out ways to train our configuration dragon. One of this is through project scaffolding using a tool called Cookie Cutter. This helps us create projects from templates and not just in Python, but also in multiple languages. So we also have an OCaml template that we've set up recently. And not only can we like template Python files, but also config files. So we're looking into ways of being able to automate some of this configuration upon a new project creation. Still a little bit of an issue with the existing code, but we always knew there would be a hurdle getting that into the monorepo. There's also repo-wide config versus per project config. We're looking to see like where we can make global exceptions. So like I said, if there's experimental code, can we just ignore all of it in terms of typing and flaking because it's just being committed to the repository to be held for long-term usage? But once we move to production, we would kind of integrate these things back in. And finally, just iterate, iterate, iterate. And if something doesn't work, reevaluate and see where you go. We'll talk about that a little bit more in a future slide as well, though. And finally, among all of this configuration, we also really want to make sure we introduce our own standard library and make sure that it is compliant and clean and easy to use. We can use Poetry to access this common library in all of our projects. You can import things with Poetry using a relative path, which is really awesome. This also helps reduce code duplication. If we have a library, let's say, to take care of some of the S3 or AWS functionalities that we have, we can have all that work in one location instead of an end location. So we don't have to worry about all of the code needing to be formatted a certain way or using the same versions of a certain package. We can put that all in one place. And yeah, so it's really great for us to be able to access common functionality there. And it's awesome. So we had some things that have been very good, some things that have been not so good, but we're really excited about where we're going in our monorepo, so I just want to share a little bit of that. So in terms of good stuff, we have very consistent builds now. We are able to, on multiple machines, just build the exact same Python package. It's very, very nice. Everything is now also PEP 8 compliant and beautiful looking Python code. That was very important to me as we first started this. So we spent about 2 or 3 weeks like going through all the Python code and ensuring it was compliant. Anything that needed to be typed was typed. And that was a very good first step. Because of the scaffolding, we're now flexible enough to include code that is experimental, which is really nice for our data science team who may not want to write like heavy production ready code when they just want to test out a few Python scripts and throw them into a repository. We do linting checks locally and in CI. This helps us catch some issues before production, which has been really useful. Python adoption is increasing in our repository, so that's always very good. We're getting more and more Python code in there every week. And nothing is on Python 2.7. It's very nice. We are very excited about that. However, some of the bad stuff here, we wrote here, indecision is the enemy of progress. And when it came to our type checker especially, like we were going back and forth for weeks about which one to pick because some people liked Pyrite, some people liked MyPy, some people liked PyType or Pyre, or like there's maybe 2 or 3 other ones potentially. These I think are the big 4. And when I said like iterating is good to help with reevaluating, you also want to make sure that you kind of commit to something for a little while before you change. Kind of all that constant flip-flopping back and forth will not make your developers productive. It won't make you productive. So kind of committing to like good team-wide standards I found is really good here. That's not to say we've been perfect at it, but it's something we're definitely working on. We're also still working on our testing standards. We hopefully will finally introduce talks and some better PyTest code into our repository soon. We're mostly like an internal group, so sometimes testing kind of gets put to the wayside, but we want to make sure that's not the case in the future. And we still have some resistance to implementing these coding standards and making everyone follow them. Some very shortened versions of questions and feedback we've received include, I need to type my Python, which some people don't like very much. What does poetry even do? It's a very good question. Why won't this run on Linux? We're working on it, but I'm still running Python 2.7. Unacceptable question. That's kind of the one thing we do stick on is like, okay, we know we can make exclusions for pretty much everything, and you don't have to do everything we're asking for if we add some rules, but you do have to run on Python 3 at least, 3.6 at least. Let's try and be a little farther in the future. And speaking of the future, we're continuing to improve our developer experience. We're adding more make commands, so that way instead of having to copy and paste a script full of commands to get your environment set up, you can run a make step. So we have make build done. Our make lint command is coming soon, so that way all that can happen. We also want to integrate and use more VS Code settings. We do like VS Code on our team for Python development. We do have some people who still use Vim though, so we also don't want to exclude their experience from our setup. We also want to unify our Python 3.x versions. We do run things somewhere between Python 6 and Python 9, 3.6 and 3.9, I should say. And so we're going to work on ways to make sure that's easier to integrate into a specific version. We do have some stuff that pulls from the future, and we will need Python 3.9 for some, so we're working on that. And finally, just adding more flexibility to our templates and to our cookie cutter project. Adding parameters for adherence to the coding standards, for example, so you could run cookie cutter with the tag like experimental, and it will make sure to add an exclusion to all of the various flaking and linting and formatting files. And yeah, like I said, making experimental code locations to exclude from standards. We may also have a whole directory we just don't want to be typed, and we want to be able to add that kind of flexibility into the coding standards, so that way developers aren't stuck trying to get things out. They can actually just write Python code and feel successful. And that's it. Thank you for listening to me babble on about our Python code for 20 minutes or so. I am not on Twitter. It is best for my mental health not to do so, but you can find me on GitHub and the PyLadies Slack at Jessica. You can also find me on LinkedIn. I have a little tiny website. And Elastic is hiring. On our team specifically, security data scientist has three data sci roles to fill right now. So if you're interested in that, you can message me either after this or during this meeting. And in general, if you're interested about coming to Elastic, I love being here. It's a great company. We're remote first, so even post-pandemic, you can still work from home if that's interesting to you. We're not super Python focused in some ways. We do a lot of TypeScript with our JavaScript or with our web application. So it's a lot of TypeScript and JavaScript, but you might find something you like. So if you're interested, you can take a look at our career page.